Okay, maybe I'll start. So, hello everyone. Welcome to the TMLS Annual Summit virtual sessions. My name is Arti Malhotra, and I will be the moderator for this talk. I would like to introduce our presenters, Rajiv Shah and Andrew Jardine. Rajiv is a leading expert on practical AI. At Hugging Face, his primary focus is on enabling enterprises to succeed with AI. He previously led data science enablement efforts across hundreds of data scientists at DataRobot and has been part of data science teams at Snorkel AI, Caterpillar, and State Farm. He is a widely recognized speaker on AI, has received many patents, and published research papers in several domains, including sports analytics, deep learning, and interpretability. He received a PhD and a JD from University of Illinois at Urbana-Champaign. Andrew is an account executive at Hugging Face, where he helps enterprise customers to understand how to leverage open source resources to build state of art ML. Outside of Hugging Face, Andrew is the Toronto chapter lead for MLOps community and has a background in NLP, MLOps, and engineering. Glad to have you here, Rajiv and Andrew. Looking forward to the talk.
Cool. Thank you for the introduction, Arti. I think Raj's bio is slightly more impressive than mine, so I'll need to work on that going forward. But good to see everyone here today. Like Arti mentioned, I'm Andrew. I'll be kicking things off. So I'll share my screen and give you a sense on what the agenda is today, and then we can jump into things. So bear with me 1 second. And Raj, can I just confirm that you're able to see that okay?
Yep, looks good.
Okay, super. So, as you all know, we're here for a workshop on how to use transformers to build AI applications today. So that's what we've been covering for the majority of it. I know we just had some pretty lengthy introductions, but just again, so you know who we are, I'm Andrew, one of the account executives here at Hugging Face, and I'm joined by Raj, who is one of the machine learning engineers at Hugging Face as well. I did want to share our contact information so that if there are any questions that you have during the session that you want to ask us perhaps afterwards about using transformers, any of the Hugging Face open source resources, or also any of the commercial offerings that we have here at Hugging Face, please feel free to reach out to us and we'll try our best to answer any questions you have. I will also be at the in-person event next week. So if you see me walking around wearing a Hugging Face t-shirt or cap or something like that, and you have questions, just kind of track me down and we can chat. So in terms of what we're going to cover today, like I said, I'll kick things off. I'm going to do a very brief introduction to who is Hugging Face, what do we do, and what are we putting out there into the open source community for you to use. Many of you hopefully will be familiar with Hugging Face, but you won't necessarily be familiar with all of the open source resources we have. So I think it's good to do a quick recap on that. I'll also do a quick summary of how we're working with enterprises as well. Again, this is one of the areas of Hugging Face that people often don't know about. So I'll do a quick recap on how we work with large enterprise customers before handing it over to Raj, who's going to do the majority of the talk today on how to use transformers to build applications. Okay, so who is Hugging Face? What do we do? Well, we are the open source community for machine learning, and our mission is to try and democratize access to good machine learning. So how are we going about doing that? So it's kind of three main ways in the open source sphere. So the first one, which you're seeing on the screen, is the Hugging Face Hub. So this is our open source repository that has tens of thousands of open source models and data sets that you can use to build your own machine learning, whether that be for NLP, vision, multimodal tasks, and other. We even now have support for scikit-learn on the hub, so loads of things you can do with the models from there. And the hub also has some functionality that can help you to train, deploy, and even demo models as well. So lots of stuff that you can do there. So the second thing that we're well known for is our ML libraries. So the most popular one, which hopefully many of you have used, is transformers. Makes it really easy to use those transform models that you'll find on the hub. But we also have around 25 other libraries that you can make use of. Things like diffusers, because we're not just about NLP anymore, but also things like accelerate and optimum. So if you're trying to do things like distributed training, we can help you with that. Or if you're trying to optimize for inference on different hardware, you might use the optimum library for that. So quite a few different things you could do. We'd really recommend you explore all of the different open source libraries which we offer. And then finally, we just try and put as much free educational resource out there on the internet as possible. So we have a really fantastic course on transformers. We just put one out on diffuser models as well. So if that's something that interests you, we'd really recommend you take a look at that. We're trying to do our best just to educate people on machine learning in general to try and build that community. So how's all of that work going? Well, pretty well, actually. So you'll see in terms of our traction, we've got the GitHub star history on the left. And even just our transformers library, you can see that it was able to overtake other really popular open source projects like Spark and Kafka, and I think under a year, and it's still continuing to grow in popularity. In terms of our hub, we've seen a huge amount of growth in that in the last year. So it's now, I think, over 80,000 models on the hub that you can use. I believe the beginning of this year, it was something closer to just 10,000. So even just this 1 year, we've seen a huge amount of growth there. We have millions of daily downloads of our models and hundreds of thousands of active daily users on the hub. And as a result of that, we have some of the best companies in the world already using Hugging Face, from research, which is kind of where we started out, and now where we're more kind of prominently used in production applications as well. So really being very widely used. So that's an overview of what we're doing for the open source community, and there's a lot of goodness in there. But Hugging Face does also need to keep the lights on so that we can keep offering all of this open source resource too. So what are the commercial offerings that we have that are helping us to keep the lights on? So here's a summary of like the top 3. This is not an exhaustive list. There are actually a few other things. If you go to our website, you'll see as well. But I think these are the most important ones to touch on today. So the first one is our Expert Acceleration Program. So this is an expert consulting service that gives you access to the 50+ world-leading experts in different fields of machine learning at Hugging Face. So if you're working on a project and maybe it's taking you too long to determine, what's the correct architecture or which model should we be using, that's the kind of thing we could help with. But also if you're maybe doing distributed training for the first time, you're not quite sure how to do that, or you're having problems with latency in your models that are actually in production, these are all areas where our experts could help you. The second one is our private hub. So this is pretty much the same as the public Hugging Face hub, which hopefully you've used. The main difference being is that it's securely hosted on your environment. So for kind of large enterprise customers that perhaps have InfoSec challenges in leveraging cloud-based open source models, this gives them a secure way to access those resources, so they're not reinventing the wheel on models every time. And it also gives their distributed ML teams access to all the collaboration functionality of the Hugging Face hub, so that if one of your teams has built a model or a data set somewhere in your business, other teams can collaborate and reuse that as well. And then finally, the last thing I'll mention here is inference endpoints. This is our newest product, I think. It is a managed model deployment solution that abstracts away the requirement for you to worry about any infrastructure for deployed models. So you simply come in, provide the model you want to deploy or select one from the hub, choose where you want it to be deployed, and then inference endpoints will provide you an endpoint API which you can call. So you don't have to worry about all of that MLOps work of deploying a model. Or if you have an MLOps team, you don't have to wait for your MLOps team to do all of that work. So you can just get models into production really quickly and start using them. So hopefully you found that interesting. That's pretty much it from me now. So I'll pass you over to Raj. But if you do have any questions about those commercial offerings or any of the open source resources we have, please don't hesitate to reach out and ask me any questions. Okay.
All right. Thanks, Andrew. Here, I'll share my screen and we can jump into this stuff. All right. Let me know if everything looks okay on my screen here, Andrew.
We can see it.
All right, perfect. All right, I put it in the chat, but one of the things I have, because I want you guys to play along as we go, you can watch, but it's a lot more fun to participate. So there's a Colab notebook, because a big part of this is a workshop, and I want to show you how to solve all these problems with code and give you something you can take home and use. So there is a Colab notebook. Hopefully most of you won't have a problem getting it up and loaded. So take advantage of the address. It's bit.ly/Raj_AI. You should be able to pull it up, and there's some sections that require GPUs for fine tuning. We probably won't get into that today. So even if this runs on CPU, it's fine. So you can run this Colab notebook. And what I suggest is two things to make the Colab experience a little bit better. So if you're a regular Colab user, go ahead and make a copy of this in your local drive. That way, if you want to, you can take notes, or if you change the code a little bit, you can have that copy with you. The second thing is, a bunch of these models are really big, okay? And if we have to wait to load them when we're ready, we'll be waiting a few minutes. And we don't want to do that. We want to keep this interactive. We want to move this along. So go ahead, once you've got that notebook open, just do a run all and go ahead and get everything loaded up that way as well. I'll move this page over here. If you run into any problems doing this, just put a note in the chat. And as we're going through this, feel free to kind of, any questions you have, any issues, put it in the notes. Andrew will let me know if there's something going on in there. We can decide if we want to kind of, take a break, answer those questions, or push them until the end. I don't mind answering things in the middle. So feel free to kind of point out things as we go like that. So, okay, good. I like the thumbs up. Thank you, Artie, for posting that in the thumbs up. I like the feedback as we go through this, because otherwise I'm just talking into a screen and it can be a little bit, I don't know. You don't know what's going on. I wish this was in person for me, but it isn't. Okay, so, all right, everybody hopefully has got the notebook. We're getting that going. Hit the run all, doing that. So while that's going in the background, let's talk about what we want to do today. So looking at the clock, right, we have about an hour and 15 minutes. And so the plan is I want you to come away with three things. One is understand some of the latest data science techniques and methods that I see. I talk to a lot of enterprise data science teams. I get a lot of views on this. So I want to just share, like, what are the coolest methods that everybody should know, or things that are coming up that I see growing and emerging and are going to be big over the next year or two. Along with that, we'll talk use cases. We'll talk a variety of different use cases, from things like document AI, semantic search, but I want to touch upon how these technologies are actually manifested in concrete use cases that enterprises are putting into play every day. And then finally, I want this to be a little bit of coding. I want you to walk away with an understanding of, hey, tomorrow, if some of this came up, I know exactly what to do, where to get the transformers library, how to get started with some models, what the code should look like to do that along the way, like that. All right. Hopefully you're all with me. Again, like, if I lose you, you feel lost, feel free to put something in the chat. We can always slow down, figure that out. But otherwise, let's dive into this. Going to be a little bit of kind of slides background here for the first 10 or 15 minutes, and then we'll go a lot back and forth between kind of coding and slides as we get to it. But while I got your initial attention, I want to hit some of the heavyweight data science concepts. So as we go through this, I like to do this in a very kind of a sampling fashion, where we're going to touch on a lot of different things. We'll touch on images, text, audio, lots of different pieces. So if I don't go deep into like the problem you're at, that's okay. Take a note of it. Find Andrew and I later. We're happy to talk more about kind of these pieces as we go through this. But I know this is a very diverse audience, and so I like to kind of make sure I touch upon things that excite everybody along with that. Yes, we will. We will talk about next frame predictions. All right. So let's talk about data science today. Like most enterprises, how is data science going? And if we take a problem like I have a house and I want to understand the value of the house, how do we do that? Like often what we do is we send someone out there to, right, with a ruler, and they go out there, kind of measure, right? Like how big is this house? Like what's the square footage or square meters of this house? Like maybe you're like counting number of bedrooms or bathrooms, but generally like we need somebody like that out there taking this like concrete 3D physical world and converting it into some type of tabular representation that we can put inside a spreadsheet that our data engineer can work with. And this is a huge part of data science. This is figuring out how to represent the problems that people come to us with. And the best data scientists nowadays are often the ones that know how to do this feature engineering, that can figure out like how to take these ideas and put them into numbers that we can then work on like that. And then once we get those numbers, we'll start analyzing the data. And for many of us, maybe data analysts, you're writing historical reports, lots of value of going back, looking at time. For others of us, we might be thinking about how can we use this for forward-looking things? Like how can we make predictions for houses that we haven't seen before, where we take this data, we build a machine learning model, and so then we can make a prediction for a house that we haven't seen before. And so this is the traditional kind of data science story. But to go through it, the steps that requires, like you have to prepare the data, label it, and then you got to do all that feature engineering, manipulation of the data. And then like you have to go train it. And some people actually like the training. That can be fun. But like lots of different algorithms, you got hyperparameter tuning, like all this stuff before you get to prediction. And then, right, somebody says, oh, well, that was nice that you did that for Chicago, but we need to do that for another city. And so that means you have to go through all this entire step over again. And a universal thing that when I talk to data scientists and enterprises and data science leaders, like they're exhausted. Like nobody's team is cranking out models fast enough, right? Everybody's like, hey, Raj, like how can we go faster? Like our team isn't moving quick enough. And it's because they're stuck in this process. And there's at least 4 outcomes that I see with this current process that I want to talk about today. One is how we rely on tabular features for understanding the world. We often focus on predicting a number or figuring out some category. This is what I call often discriminative AI. It's that long life cycle to a prediction, right? Like all that data prep, it takes a long time. And then this only solves one task. If our tasks slightly change, we have to go back and kind of go through the process to build a new model again. So this is what I want to talk about today, is how we can use some of these things to kind of knock these things out. And the way it's going is because AI is evolving, and I'm not going to go into a big history lesson here. We know that really large data sets, GPUs, new deep learning algorithms, these things have all helped together. There's lots of models out there that we know that over time, building larger models has helped us get more accuracy in a variety of contexts, from images to audio to NLP, like that. And if you want to think about it, one way you can think about it is in the old days, often the models only had a few parameters. You could think of them as little buttons or switches. And what we figured out is how to make these enormous models, right? The biggest of these models literally have billions of these parameters. And you can think of it just like room, like after room of like switches. I mean, that's how complex these models are. And that's why they're really good, for example, figuring out the nuance of language and, how things work. And I think there was a blog post today on how good AI is at diplomacy, right? A game where all it is like chatting and talking with people and intrigue and figuring out how to kind of manipulate people a little bit. And that's because of all these parameters, this understanding of language that they have. Okay. So that's some of the background. Let's get a little bit more concrete and talk about, now I've given you the problem, some of the stuff there. Let's talk about how we use this. Like, if you're a data scientist, like, what are the things that you should be thinking about kind of when you're talking with customers about what we can do with this stuff? So my youngest son is about 7 years old, and 7 is about the same age as Alexa. And so my son has grown up in a world where we routinely ask Alexa to, for example, like we have Alexa like turn on the lights or kind of play music or turn off the fan, like ask for what the weather is. And so he's grown up in this world where it's perfectly normal to talk to Alexa. And in fact, like he talks to Alexa. Like, I mean, he asks it to play like the fart songs, of course, right? Because he's 7. But for him, talking to Alexa is no different than talking to anybody else. And in fact, I get a little worried about it. And so I make him say like, please and thank you, because I don't want him to like, you know, like just like, I mean, we kind of bossed Alexa around as grownups, but like, I don't want him like treating people like that. But it's just a sign of like how good these technologies are that we can just talk to it and understand it. And in the same way, like I look over at my daughter who's a little bit older, and if I watch her doing things, she'll type something like this in for a search. And like I've been around for a while, like looking at a search query like this, like a little bit of me dies. Like why would you have such a search like this? Like why would you use something like eat better? Like that's such a vague term. Like what do you mean by eat better? Yeah, are you trying to get more energy? Are you trying to lose weight? Is it about like vitamins and minerals? Like there's something that you have to think about, right? That you're some goal that you have with eat better, like that should be part of your query. Like, why would you use Xmas? Like, come on, like you're going to limit yourself to like a subset of searches when you do that. Like, and you know, I grew up where kind of that's the way search worked. Like if you used Xmas, you weren't going to do it. But if you try it nowadays in pretty much any modern kind of search engine, you'll see that it works, right? Like the technologies today know that eat better is close to healthy, or that Xmas is close to Christmas. And this is like a remarkable way of doing this is because these technologies understand language. And we're going to go through how this works, but this is basically is we're converting all the text that we say into a numerical representation. And when we put this into a numerical representation, we'll see that concepts that are similar are often kind of grouped together in these spaces. And that becomes a very useful attribute when we want to do things like semantic search, where now I can do a query around eat better, and it knows that the relevant document is healthy by taking advantage of these embeddings. And if you look at search engines nowadays, right, this was the biggest change in Google, who had spent like the previous 20 years building search, was when they brought in BERT to help do this type of semantic search. Whether it's Meta, you know, Zappos, Spotify, like everybody here all uses kind of semantic search nowadays. And it's based on this idea of these embeddings, like finding a way to represent our speech. And this has other uses. Question and answer systems are now kind of another growing part where people are building these, where you want to ask a question, pull the answer from other types of data. If you work with recommenders, often the information that's being used inside recommenders is an embedding. It's a representation, whether it's of images, whether it's of a text conversation, are all kind of common ways to pull that stuff in. And so for me, this is kind of how that world is changing, is we're now, instead of just using those tabular features where somebody with a ruler is counting, we can use this concept of embeddings to do this. Okay, hoping I'm not losing you. I got one more cool thing I want to talk about, and then we'll go into a little bit more hands-on back and forth. And hopefully most of you have all seen this kind of thing. I mean, this is where I kind of wish I could see your faces, right? This is GitHub Copilot. It's one of the auto completions that are out there for code. It's SageMaker has their own version of it. Like Replit has their own version of it. Like most of the coding technologies have this, but it's essentially autocomplete for code. It's pretty cool. Like you can even like tell it like, hey, here is an English description of what I want. Will you convert this into code for me? And like this stuff works. I mean, in another context, I've seen this with, they took math problems at MIT, like the first year math problems, like calculus. They took the word problems from there, and they did something similar to this, where they had it write out a program for each of the word problems, and they found out the programs were like 80% correct, and they were very understandable for like how to solve the word problem. So this is like totally cool, like how we're able to kind of use computers to kind of get at this. All right. I'll answer that question a bit. Good. Now, this kind of code completion thing, Google actually spent some time testing it out on their own developers to see how much value it increased. And Google, you have to remember, makes like $250 billion a year, largely on software, right? So for them, even a little bit of a change is a big dollar. And they found out that they had a 6% productivity when their software engineers were using these tools. And if you look at their code base now, 3% of that is auto-completed. And they're not stopping there. They have other tools now that they're looking at. So if you want to, for example, go from one version to the next version, can we use autocomplete technologies to go ahead and do that rewrite for us, for example? It's just, the world is really opening up with these code completion technologies. But it's not just there, right? All of us probably on our phones are used to using some sort of autocomplete. And this stuff is getting better and better. So this is Jasper. They're an AI startup in the copywriting space. And what you can do with them is you can say, hey, write me a paragraph about this. And it'll write a paragraph. I mean, my heart goes out to like the English teachers and like first year college, people, like how you're going to deal with this, because these technologies are able to write stuff that looks like, facts might be wrong. That's an important part, but it looks like pretty good writing. And I have lots of customers that are actually have people that work hand in hand with these writing tools, and they're humans, to be able to write things faster and quicker and better together like that. So it's totally kind of out there, code completion, right? Like in the same way, you're all probably very familiar with things like text to image, of how we can use these texts to do that. But this stuff is getting more complicated too. Like I just saw this paper last week where they have these process flow diagrams. And these process flow diagrams can be represented with text. Like you can think of it, there's a shortcut text style. Oh, it's right at the top here for representing what it is. And you can train an auto-completion technology in the same way, in this way to complete the flow sheet. Again, we have to worry about mistakes in that piece there. But hopefully you're kind of starting to see like, how these pieces of technology can come into place and change things along the way. And so this, for me, is huge, is the space of generative AI. And it's going to take a little bit of a mind shift for data scientists. I mean, we're often used to like, hey, let's solve a problem by figuring out what number the customer cares about or what category. But like these solutions, just generative approach is a whole new way of thinking about like how to help people inside an enterprise as well. All right, so let's have some fun now. Let's stop listening to me talk the entire time. Let's check out some of these technologies and kind of play with them ourselves. And I'm going to look over at the question here. So there was a question by Shrikar, for places with lots of tabular data, is there a good path for migrating towards an embedding-based representation? So I've been in data science for a long ways. I think there's a lot of value in old school approaches. So I'm never one to quickly abandon the current methods that you're using. But I think it makes sense that, if you want to try, for example, an embedding-based representation, well, you can try that side by side to your existing tabulars and see how much of a lift it gets. Not every embedding approach is going to give you a lift over a conventional approach. Sometimes an embedding approach might not add, more information, right? I'll give you a simple example. Like you could build a big fancy embedding of like that house that I talked about and get all the structural characteristics of it. But if you also know like the zip code in the US, like where a house is, you can generally get some like median value of like, is that house really cheap or is it going to be really expensive by just that? It's noisy information, but depending on how you're using it, might be okay. So, I think this is where you want to empirically test any of these things as you're trying them out as well. All right, let's go. Let's go. We're going to go to huggingface.co tasks. So follow along with me. This is a hands-on part of it. So I'm watching all your computers as we talk here. You can go to hf.co. If you prefer a fuller thing and you're not so keen on abbreviations, you can type in huggingface.co as well and start there. I put this into incognito mode just so I would see it like for all of you for the first time. Many people will have accounts, and I'll show you there's some advantages of having an account. But for what we're doing today, you don't need to do that. So this is the Hugging Face website. Andrew talked about it earlier, right? There's models, data sets, spaces, a lot of good stuff, plenty of things to explore. All these things are available kind of for free. But what I want to do, oh no. Oh yeah, that's okay that you hit that error. That's in the error in the notebook is fine. It's later on, and I'll talk about that. So let's go over here, and I want to go to tasks. And I like tasks because I think it's a great place to kind of start out to understand what's possible around transformers, around diffusers, around all this new stuff that's going on in AI. When you move beyond XGBoost, these are all the kind of the cool things that are going on here. And this page is laid out. You'll see kind of there's a section around computer vision, NLP, right? Audio, multimodal as well. For those of you who want to contribute to the open source, need to find a first project, you can see a couple of these. We're still looking for documentation. Merv on our team, she's been working to kind of recruit people and have them contribute often for the first time into the open source by doing that. So feel free to do that as well. So let's talk about these tasks and what they are. I like to think of them as kind of building blocks for building these AI applications. I'm going to go to this one here to start with, the automatic speech recognition. You can see there's a lot of models in this one, but let's go to automatic speech recognition. Pop this up. And what I like about this task page is if you didn't know what automatic speech recognition or ASR is, there's a nice, easy introduction, right? Like exactly what the input would be for an ASR model, what the output's looking like. If you're somebody that prefers a video, you can listen to Omar talk for a few minutes about automatic speech recognition, right? We often list typical use cases that you'll find as well along this. And there's code snippets, and we'll talk more about that stuff here in a few.
Yeah, I'll just jump in here actually, and kind of a little bit of insight of what we see from working with customers is in the consulting service that we have, one of the challenges that we often see our customers having is that they're spending a lot of time figuring out really which models to use for their tasks and how do they go forward with that. And that's often something that we'll help them with. So we have tons of experience and we can direct them to these are the best 2 or 3 models for a task, and we save them a bunch of time exploring architectures and models that wouldn't be useful. But this is also a really good way in terms of the open source community. If you know you have a task, this helps you hone in on the models that are going to be most useful for you. So you're not spending tons of time exploring models and testing them out and seeing what the performance is, when we can kind of direct you to the ones that are going to be most useful straight away.
Yeah, no, that's great, Andrew. Thanks. So, and an example of that is right at the top here. And there's a model here, this Facebook wave to Vecchi thing here. But if you want to just try it out, look, I can just try it out right here in the browser, see, is this thing kind of working? And then let's go ahead and run the compute. There you go. And this is doing automatic speech recognition. This is a machine learning model. It's just like a set of neural network with weights. It's not like some massive application like you might have had back in the days for doing automatic speech recognition. And if you don't believe me, just click here. This is the model page for it, where we'll see that this came from Facebook. They shared this out, open sourced it out. There's a license here. It's Apache 2.0. Like, here's the full description if you want to understand about it. Here's the code snippet. Like, hey, I want to go use this. You can cut and paste right here. Quickly get started with this. And you'll see here there's evaluation. If you're evaluating it, there's results on different data sets. There's web spaces, kind of web demos with that. Lots of things. I'm going to slowly introduce all these. We're not going to hit them all here, but feel free to kind of go around on this like that. So I'm going to do one more task to kind of give you a little bit of a flavor of something else. So that was an audio task. Feel free to kind of click around as I'm talking. You don't have to follow exactly what I'm saying. You won't get lost. I like to do a computer vision task as well. So let's go to object detection. And if you're not sure what object detection is, again, like it tells you, like it says you get an input, image as an input, outputs images with bounding boxes and labels on detected objects. Right? So it saw that this was a cat here with kind of a high degree of confidence as well. And same thing, I can go watch Nate. I can see use cases. We'll do this in a second. We're going to go over and do the coding for this. But again, like if you're brand new to this stuff, this is kind of where you can start to walk before we start running using code like that. We can go to the here. You'll see there's other tabs here. Like if I go to files and versions, I can go and directly download the full weights of this, all that stuff. These are just basically GitHub repos that you can manipulate. There's a community thread as well if you have discussions around this stuff as well. So that's, and we'll keep going back and forth to the hub, but I wanted to introduce the hub and kind of an easy way to start using it for getting to know these different tasks. So let's jump to, because I know there's a lot of data scientists. I saw there's people that like GPUs on their bios. So let's go ahead and we're going to shift over and go into the notebook here and do it with the notebook. And please keep the questions coming. If you hit run all, you will eventually hit an error in the notebook. That's okay. I have it set up like that. And we'll talk about that in a little bit, why it's like that. I have the outline. I like to keep the outline of the notebook up and running here. So that way you know where I'm at. If you kind of are busy looking at your own notebook, flipping back and forth. I've built this notebook. So after you leave this, if you come back in a couple of days, spend an hour, reinforce what you learn, you'll also have lots of links to other useful resources as well. So for example, I've linked the official Transformers notebooks here. My colleague, Julian Simon, he's done a wonderful set of notebooks using SageMaker on doing a review data sets covering various aspects of the entire kind of ML lifecycle all the way through his notebooks. Niels, who's on our team that spends a lot of time when we talk about transformers and the models that are there, he's the one that goes in and he codes a lot of the models, cleans them up. He has lots of test notebooks as he's doing this stuff. So it's kind of an insider tip. Most people don't know about them, but they're another great source of kind of notebooks as you're going through this and doing this. So let's use this. Go ahead and just scroll down. We don't need to kind of look at this. This other stuff is just loading everything up. And I'm just going to go down this. We have some verbiage here on the pre-trained models. You guys get it. I've been showing you that stuff all the time. So let's go right here to the sentiment analysis. I think I changed my notebook. There. Oh, I don't like that. Why does it do that the second time? Okay. It's annoying for me. Like when you run this, apparently it's like the second time you run it. I don't know. The first time it didn't run this. So let's talk about what's going on. I'll explain what's annoying. So what we're going to do is we're going to run sentiment analysis using the Transformers library. So I've already done a pip install. And from Transformers, we're going to import pipeline. And we're going to use pipeline because it's a very easy way to kind of get to these tasks. And so I'm going to say a sentence classifier here is equal to pipeline. And then let me go. I hate, they changed it somehow, and now it has all the verbiage about the model and the model weights and stuff, which is interesting. But like today, I just want to focus on this part right here of showing you how I am sad about having. Feel free to kind of use your own text and play around with this as we go. I am sad. So ideally, when we do this here, it will realize that this is a negative sentiment. Now, we did this in about 3 lines of code. We were able to classify the sentiment, is it positive or negative? That way. Like, if you wanted to do this a couple of years ago, it would have taken you 20, 30, 40 lines of code, much more complexity to be able to get to the same result. And this is why transformers are so popular, is because it makes it so easy to do a lot of the common tasks that you have to do as a data scientist. And here we're kind of, the way it's working here is how's it getting the score? What's the magic behind it? I've kind of hit it up here. That's because in the background, what's going on is we're downloading a model and supplying a model. And if you're curious, you'll see here in the language, it tells you exactly what model it is. And so this part of transformers, this is, what's the word? It's like managed or something like that. Like it's caretakers. Our team is like busy, like checking out the models, deciding which one should be the default model. So you can have a pretty good sense of the default models in transformers is something that's probably been vetted quite a bit. You can see in this case, right, this is the model that gets like 8 million downloads last month to do that. But if you're curious, like, hey, what's the sentiment model that's being used? You can go in and read all about this model and what it is here on the page like that. So that was sentiment analysis. Let's do some other ones here as well. So the text generation is that auto completion that we talked about. Remember that code auto completion, or like the sentence on your phone? That's what this is doing. So I told it like once upon a time, and then it finished the story. You heard me say there's only, right? You can see the language here to do it. And if you run it again, it'll be a little bit different, and you never know exactly what you get, but let's give it a shot and see what happens. And feel free to run your own auto-generate. It's often great fun if you find something that's funny and appropriate to share it out in the chat as well. So this one's got like a little bit more of a religious vibe, right? Like the power of heavens and earth have to do that. Let's do this in this course. So take a second to do this, but if you're kind of curious, like how these things are working, how this auto completion is doing that, you can go in and see this is using GPT-2 model. Now this model has been taken from the Hugging Face Hub and it's been downloaded into our Google Colab instance. So this model now is running locally in our instance, and you have that code. You can go grab that code and do this. And if you work in an enterprise that needs everything air-gapped and fully private, you can grab the models, run them locally, and do that sort of thing. Okay, let me stop here, take a break, see if Andrew has anything. Before I kind of keep moving on. I feel like I've been pushing hard.
Yeah, I'll just add like one little tidbit which I think is interesting, because I know there's a lot of hype around the GPT series of models. GPT-3 obviously has been out for a while. People are still pretty crazy about that, and it can do some honestly really impressive things. GPT-4 is rumored to be coming out soon, and we expect that to be one enormous, but also probably able to do some even more impressive things than GPT-3. And I think that's an interesting context, because what we actually see at Hugging Face is that for the most part, whilst GPT-3 and kind of similarly large models are really good at kind of doing general tasks and they can do a lot of things well, for the most part, they're generally not the best model to use for any individual task. So if you're looking to do question answering or make sentiment analysis or something else like document AI, like often you'll find that there will be a much smaller model that you can fine tune for your specific task will actually give you better performance than just using GPT-3 because it's so general. I'll put one kind of qualifier on that, in that GPT-3 is very good for like generative conversational tasks, and it probably is the best for that. But for lots of other things, it honestly isn't the best one to use. And so we spend a lot of our time kind of advising customers on, which model should you use? Because they often will come to us and be like, oh, we wanted to use GPT-3, but then we felt we couldn't because there was the paywall and we didn't have access to the model. And actually, it's not really a problem, because in most cases, there is a better, smaller, cheaper model that will have like less latency and is really much better fit for your task. So I thought that was just interesting to mention, because I think often people don't realize that.
Yes. It's a great point. And I saw RT ask the question, and we're going to cover that here in probably about 15 minutes. Is we'll talk about some of the existing pre-trained models that are out there and how you would kind of make a model for your specific task as well. So yes, good point. All right. So I know there's people that wanted to do image stuff. Here's an example of an image classifier. And what it's just looking at my little fat cat here. I'm going to grab this cat. I'll show you what it looks like. See, little chunky cat here. And if you look at the notebook, and then it's kind of way down this, all this model stuff, we'll see that it's figured out that it's a lynx here is kind of how it's categorized that over a cougar, snow leopard, Egyptian hat. But again, this is out of the box. I'm just grabbing a pre-trained model and doing that. And now this next one is my favorite kind of pre-trained model that there is. And this is for visual question answering. So in this one, I'm going to take that same picture here. And if you have other questions, have it as well. So I'm going to just ask it, like, what is the weather like in the picture? And so what this is doing is looking at the image, taking my text question, using that information to figure out what's relevant in the image to answer my question. So for me, this visual question answer is like totally mind-blowing stuff that you can play around with. But you can see here, come on, get down to the bottom here. It says it's snowy and cold. Like, it figured that out by looking at the picture. I just, for me, that kind of stuff is so cool that it's doing that. I like that. Okay. So those are the pipelines. Those are some of the pre-trained tasks. There's a ton more. If you have time, check out the task page, check out the pipeline code, play around with more of those pre-trained ones as well. If you're interested in embeddings from the pre-trained models as well, there's code here showing you how to kind of get the image embeddings. I'm going to kind of just skip over that right now, but if you have a need for that, I've got pieces there. But what I want to do is talk to what Andrew just brought up, like, how do we get these things for our specific tasks? And so let me go back to the slides here, and I'll talk us through this. So let's go back to our pre-trained models that I showed you. What I like about them is off the shelf, you can grab them very fast to get a prediction. But sometimes you might need to modify them, right? Like, everything off the street doesn't work for us. And so let's talk about that. One of the things I like is Indian food. Like, if I want an image classifier of Indian food, well, there isn't a pre-trained one. Like this BERT, one of the best image classification models, was trained on ImageNet 21K. And we can go into like a whole cultural hegemony thing, but like, there's no Indian food in the 21K. So if I want an off-the-shelf classifier for this, like, I'm stuck. Like, there's nothing there for me. Similarly, if I'm somebody from the finance market, and this comes up all the time with our financial customers. Well, if you ask a machine learning model what market is, like, it's confusing. Like for most machine learning models, because if they're trained on Wikipedia or tweets, I mean, the market is really about like where people go to shop. But if I'm sitting inside a financial services company, like, market's a totally different meaning for me like that. And you might want your machine learning model to reflect that understanding that you have. Now, what we figured out, and hopefully most of you kind of within data scientists know this, that you can start with these large models that are, for example, trained on English Wikipedia and books corpus. But if I have a slightly different task, if I want to predict the sentiment of stock prices, are they, is the stock price going to go up or down? What I can do is actually take a task-specific data set, retrain a little bit of that large model. There's different methods for doing this, but this is what we call fine-tuning or transfer learning as a way to kind of tune this large model to that specific task. Transfer learning, widespread. I think hopefully every data scientist is familiar with this. It's one of these things that's really kind of shifted the curve, where with transfer learning, whether you have almost no data or whether you have lots of data, you can still learn a lot from those original large models and transfer that knowledge over to your specific task. So it's kind of very widely used like that. So an example that I want to show you of is a finely tuned model where the goal is we have some text, and this isn't sentiment like happy, positive. This is sentiment where we have experts in the field, in the finance field, that have looked at news stories and said, is this phrase likely to raise a stock price or lower a stock price? Because you can think about this, like if you have a good model of that, and there's so much news coming out, that can give you a little bit of insight into where a stock price could go. And I've worked on these types of models with finance companies where they build it based on their own expertise, not just sentiment out of the box like that. And the way it works is they have some objective they want to classify, and they'll take a large model, whether it's BERT, whether it's FinBERT. We can talk a little bit about the differences of this. But then they'll have some task-specific data set where they've retrained that large model for that specific task. And if we look across the Hugging Face Hub, that's what most of the models that are actually on the Hugging Face Hub are ones that have been fine-tuned for particular tasks. And whether it's finance, whether it's healthcare, that's where you'll see lots of different models that are out there. So let me just show you that both on the Hugging Face website, and then we'll go to code as well. So if we go to the Hugging Face website, if you click under models, for example, like 91,000, man, the thing's just booming. But like if I wanted like that Indian food is the one here. You can see when I type in Indian, there's like 41 different models that have something to do kind of with Indian food. And then I could, if I want to, then I could kind of use the image classification ones as a way to kind of search down what I want to do. This kind of faceted search on the left is very useful like that. If you're somebody, I think, right, there was a healthcare one. If you're in healthcare, maybe you're looking for something like BioBERT. Well, this is where you can kind of use the search ability here to be able to look and find those. When you're finding these things, people often ask me, how do I know which is a good one, which is a bad one? Like I use like the downloads, like, is this a popular model or not? Just as a little bit of a signal from the community is one piece. But then it often differs. Like models differ on accuracy, on inference speed. There's not one model that's perfect for every situation. And so that's where it's often a little bit of work on your end to kind of look and doing that like that. So one of the questions was what are the challenges in monitoring these large models that are third party and unaudited for regulatory compliance? So there's monitoring, but there's also like regulatory compliance. So let me go with that vibe first. The models that are on the Hugging Face Hub that people go and use, these have all been shared out by the community. They often come with different types of licenses. So in this case, this one has an MIT license, which means I can use it for commercial use. There are other licenses that are on the Hugging Face Hub, and they say it explicitly. They say not for commercial use. Like if you're a researcher, go for it. But if you're a big corporation that's sucking money out, no, you're not using this model, right? And that's the prerogative of somebody who creates it to decide, what the licenses should be. So that's one thing. Another thing is like, how do you know that you're not just getting, a virus? So one of the things we do is we spend time scanning them. We even added some new capabilities around pickle files to better detect that stuff. So that's another kind of way we think about them. The other is, how do you know if it's a good model? Well, try it out. I mean, look at the downloads, try it out for your use case, see if it works, is often kind of the simplest thing if you can't get enough feedback from how widely it's used in the community. Hopefully, Srikar, that helps your question a little bit.
Yeah, I would add maybe one thing onto that as well, Raj, which is there's also like the ethics and bias component to using a model in production. Like, how is it going to perform, in your situation? Maybe it's going to treat your customers in a particular way or your users in a particular way, or if it's a generative model, is it going to produce text or images that are in some way offensive? Those are all things which should be considered. There are some tools out there that you can get for monitoring that kind of stuff, like model monitoring tools. We also have experts like Meg Mitchell inside of Hugging Face who does quite a lot of work on that. So, if you're interested in figuring out how do you monitor or work around those kind of risks, then reach out to her. She might be able to help you with some things.
All right, cool. So you can use the hub for searching for those models. Then you can see here's a little bit of code for grabbing that sentiment model that's fine-tuned, where all I'm doing is I'm using the same pipeline approach as before, except now I just specify exactly what the model is, what the tokenizer that I'm using, and I can do that. So here's another example of a fine-tuned one right below. This one, I did it for kind of the Indian foods, where I went ahead and identified, here's the particular Indian food model I want to pull down. And look, and if you want to go see what it looks like here, I can. Hold on. That's my data set. There we go. Oh, so here's the model that I have sitting out on the Hugging Face hub. You can see here's the code right here. If I click on that using transformers for grabbing that out, the feature extractor and the image classifier, I could literally just cut and paste. I literally did cut and paste that, put that into here to be able to pull that down. And then we can grab an image. And in this case, I go to the data set of food images. Let me show you that data set too. I should have that linked here. Oh, I did. Do I have it linked here? No. God. Well, you have the Indian food images data sets here. And you can see here all the different foods, kind of what labels they are right here. And so that's where I use that when I was training the model. I use that for kind of testing it out as well. And so that's why kind of in the code here, you'll see we're loading this particular data set here and testing it on that as well. If you want to do your own fine tuning, you have your own specific task you want to do. This is where, for example, for image, I have a notebook, I have a video walkthrough, lots of resources around that. But this also gets to kind of where, I know it does get hungry. This is especially, right, like lunchtime-ish kind of thing. This is also where the last part of the notebook and where the errors are is all about fine tuning. And we'll talk about that in a few minutes as well around that. But this should give you an idea of how you can use those existing models. Here, the last piece I have here is using a fine-tuned sentence transformers with setfit. So setfit is a very kind of new, novel way of dealing with when you only have a little bit of training examples and you want to build a classification model. Here's an efficient way to fine-tune a sentence transformer. So if you're looking for kind of doing a sentence transformer, so I've given you a text model, an image model, as well as a sentence transformer around that as well. So let me pause here, see if there's any questions, and then I have some code on how to do the fine tuning. We have some spaces we can walk through, and then plus I have a tons of advanced approaches we can talk about as well, like that. But let me pause here, see if there's any questions, because I know we only have a half hour left, and I want to make sure I have like 2 hours worth of material left that I can talk about. Okay. Is everybody with me? Let's actually walk through the code a little bit on the fine tuning, since there were some questions on how we do that. Like that. So suppose you have your own task you want to fine tune. Let me show you how you can do that without writing a ton of code using transformers. And at this point, I'm just going to walk through it. I'm not going to actually kind of run it, simply in the interest of time to do this stuff. But you should be able to do this. Now, the first step in why everybody's thing broke at some point is we want you to get a Hugging, or we don't want you to, but it's optional. But if you can get an account on the Hugging Face Hub, what you can do is once you build your model locally or in Google Colab, you can then push it up to the hub, so that way it has a place to live. Because otherwise, once you leave Google Colab, your model's going to be gone like that. So we want to have a place to upload the final model. Hugging Face Hub, you can think of it as like the GitHub for AI, allows you to store your models up there. So you'll see there's a couple of clicks here to get an account. And once you do have an account, then you can have authentication tokens that you can then use when you're building things. And so that's what that piece does, is it gives you that authentication token. And if you don't have that, one of the later lines will get you. But then at this point, to fine tune a model, what you're going to do is you're going to start by grabbing some data. So in this case, I grabbed the financial phrasebook data set. I pull that down. I'm doing a little bit of train test split for that, kind of just simple data manipulation. But I get my data. I get with a pre-trained model. And in this case, I chose Distilbert. Distilbert is kind of a distilled version of BERT. And often people like it because it's smaller, it's easier to use, which means inference is faster, it's faster to train it. But like everything in life, there's a little bit of a trade-off in accuracy. So this is where you can play around with different ones. For the notebook, to make it quick, I use Distilbert. Then we have to tokenize the data, right? Tokenization is an important step in NLP. We need to kind of convert all the words we have into nice numbers in a way that's kind of blocked off for the computer to understand. Now, one thing is that if you run this yourself, you'll see that I have this little bit of thing here, this select range 1000. And that's what I'm doing, is I'm just grabbing 1000 examples from the training set. So training set has a lot more, but I'm just grabbing 1000 because this notebook's made to run very quickly like that. So yes, Andrew, thank you for asking that question like that. I'm curious too. But then we set an evaluation criteria, what metric we want to use. I used accuracy. There's lots of other metrics that you could use. And once you have that, then all you do is give it some training arguments around kind of, and here there's a million training arguments you can go and use. Here, let me see if you can see all the different training arguments here, right? So if you're an advanced user, there's tons of stuff to get into complexity. But if you're just starting out like me, you can start out pretty smooth. I trained it here for 1 epoch. You can try training for more, seeing if that improves performance. The model's getting pushed to the hub, and that's where you're getting that final error, is because it's trying to push to the hub, but you're not logged in, so it can't push to the hub like that. I give it, what my training data set is, what the eval data set is, what I'm computing the metrics. So hopefully kind of pretty understandable training arguments here that you can run. And that's all you have to do to kind of fine tune a model. Give it a little chance to run. You can see I ran this earlier here, was able to kind of get my accuracy scores. If you go down the notebook, I'll show you how to evaluate the model. I create a quick kind of confusion matrix to help you understand it and use it locally as well. So just pretty much the basics on being able to kind of fine tune a model. There's lots more resources, but just want to let you know that it's not an overwhelming task that takes 100 lines of code that's like super complex to do. The Transformers has made it very easy to kind of be able to fine tune models using the trainer. And there's links in the notebook, but if you want to do things like you want to do multi-GPU training, there's links like to Accelerate and other tools like that for doing that sort of thing as well. All right. Question on IoT time series data. Many of the deep learning models are in images and text. So when we talk about kind of transformers and where it works best, and I think a little bit of it is you can see the page here for the tasks. You can see these are kind of areas where it works the best. Now, there has been some movement on using transformers for time series. It's a pretty new approach and really works best when you have lots of data where you're going to be able to really use deep learning to pull the signal out. And you have to have a complex problem. If you have a simple problem, even if it's a lot of data, simpler models work. And so that's why you haven't seen kind of time series take over, transformers and time series take over as compared to traditional techniques like that. So yes, it's there, but it's not the lift that you get versus working with some of the unstructured data like text and audio, which is why you haven't seen it. The push to the hub isn't necessary in that bit of code that I gave you. It's just if you're using Google Colab and you don't have the push to the hub, you need some way to kind of remember to save your model when you're done at the end, or otherwise you'll lose it. So that's why I often kind of get in the habit of putting it that way as well. You'll see if you use like SageMaker and things, you can push this into SageMaker or S3 buckets, and there's other ways that people will do it like that. So check out some of the other notebooks like that. Okay. I'm going to skip over this no pre-trained. I want to show you guys spaces, but let me hit one. I'm going to skip slides. Let's go over here real quick. So I think Andrew mentioned it a little bit. Lots of concerns when using these models, just so you're aware, right? These models have been trained on historical data. In this case, right? It thinks all genius scientists are men. Just last week, Meta released Galactica, which the goal was to summarize academic literature. They didn't clarify enough that this thing makes errors. Like a lot of the summarization can make factual errors. And they ended up with kind of egg on their face and pulled the demo down from that as well. Now, there are tools for explainability that you can kind of jump into as well. But, this is an area, especially when you get to the large scale models, there's just a lot of knowledge that's underway that's being done. It's just really hard if you're in academia, for example, to be able to research and understand how these models are going. And this is where Hugging Face has been spending a lot of time and effort building open language models. Bloom was released about 3 or 4 months ago, and it's the world's largest open multilingual model. It's 176 billion parameters. It's humongous, but anybody can go and download that, play around with it as well. We've just kicked off a new project, and if you're interested in this, they're still looking for collaborators. Is Big Code, which is going to build an open language model that's focused on code, so like Python, Java, that kind of thing, those code completion ones like that. And they've already put together a humongous data set for that as well. Okay. The last thing, and I just want to tease you with this, we're going to run through this in about 6 minutes, is some of the cool things that are coming around the corner. I just want you to be aware of. You're all aware of these image to text models, this melding of images to text together in models, leading to all new types of things. But we can also translate that into everyday enterprise tasks, like taking an image, asking it a question like, what is the invoice number? And it comes back with the number. This is a real kind of one I'll show you at the last minutes here, something that you can try yourself. And this is where in document AI is blowing up because you're able to take images, ask questions, be able to pull this information out. And it's because you're using these multimodal approaches that pair the knowledge of the image world with the knowledge of the text world together to solve these problems. Just did a huge blog post. If you go check the Hugging Face website, the blog website, I just did like 10-page blog post about document AI with the rest of the team. So check that out if you have more interest in that. But what this is getting at is the representation issue I talked about earlier, where we have tabular information, but we can now combine different types of tabular information, text, vision, audio, all this stuff into these multimodal models. The other thing that's happening is multitask models. So models that can solve multiple tasks at once. So Karpathy at Tesla AI Days talked about this. You giving the example of with computer vision of instead of having separate models for each of these tasks, like let's just put this into one model. And so this is another piece that I see is like where we have lots of models, like going to multitask models is another one. These guys have all talked about it. Sean Taylor of Lyft, Bay and Bruss of Capital One have all talked about how they want to move towards this world of multitask and multimodal models. The last thing is, and Andrew mentioned this earlier, are these large language models. There's a ton of cool stuff that's coming up with these. And here you can think of like the GPT, 3s that you've heard of, but there's a couple of others largely owned by large companies. But these large language models that have lots of different use cases open to them, for data scientists, it's important to recognize they learn, or we can use them very differently. So take the movie sentiment example. Often to train a sentiment classifier on movies, I have to go and find a bunch of positive movie reviews, find a bunch of negative reviews. Right? We pass that over to an algorithm that learns to tell the difference between the two. In these large language models, they already understand the world and language very well. And what we can do is just by using, like, whether it's something called prompting, whether it's few shot, we can just coerce that information out of them very easily. Instead of that traditional training, we can ask it questions like this, where we can say, hey, this is the type of, if I give you a review, this is the type of answer I'm looking for. And by kind of warming up the model to that, it will then start talking to us in that particular way. And this has been kind of a huge revelation. And this is where a lot of the cool research around language models still haven't figured out exactly all the good, useful enterprise use cases. Is figuring out how to use these language models like that. Okay. So hopefully what I've done today is given you a ton of different ways to think about like how we can solve problems, whether it's pre-trained models, whether it's transfer learnings, these large language models with that, like that. Now, I want to spend the last 10 or 15 minutes showing you some ways to apply and to kind of dig into this stuff like that.
Hey, Raj, we've got a few questions in the chat. Do you want to save them to the end, or do you want to take them now?
I will. I'm gonna fire up the spaces. So if you go down here on spaces, I want to show this for the last few minutes, and I'll answer those questions. I think I can answer those pretty quickly here. I'm going to open up a couple of these spaces and show you what spaces are, because I think that's important to realize. All right. So let's go through this. Does the video classification use audio and visual features? I haven't played around with that. That's a new task and a new thing that we've added. I haven't tried that out. My guess is it probably does, but I don't know that for sure if it does or not. Reinforcement learning models. Okay. I can't talk very well to reinforcement learning. I will point out that if we look at the courses that we have at the Hugging Face website, did they not get a page? We have a reinforcement learning Hugging Face a class on deep reinforcement, and it's being relaunched in the next couple weeks as well. So that's a great opportunity to learn more about kind of what's going on with deep reinforcement learning at Hugging Face. They're relaunching the class. The other piece is for these questions is we have a forum you can go to and a Discord. And I know a bunch of the RL guys hang out on the Discord as well around that. For the explainability, you can, I wrote a paper, I wrote one. I find my own work. If you Google this explainability and my name, you'll find kind of a blog post that goes through and identifies a number of easy packages and code solutions as well to get you started with explanations for that as well. All right. Keep the questions coming. The last part of the Hugging Face website I want you to all be aware of is the spaces section. And you're probably all gone there because you've seen like Dalle Mini or some of the Stable Diffusion stuff. But this is where we host web demos. And any major research paper that's coming out nowadays is pairing a web demo along with the paper. There's even a link in archive papers now to show where your web demo is. Besides that, if you build a cool project, make a demo of it, share it out. These demos here get a lot of attention out there. And the great thing is if you're new to something like, hey, I have to build something for forecasting, you can go and check out these here. And yes, you can see the demo, but you know what? The code of all of this is available. Like you can literally if you're an enterprise data scientist, you can just grab the code and show it locally on your laptop and impress somebody with what you've built like that. So I think it's great to understanding what's going on, but I think it's also a very useful learning tool like that. In the notebook, I've linked a couple of my favorite ones. So I've linked this doc query one, which shows you that example that I showed in the presentation around document AI. So if you're interested in that, if there's people that are working in that space here, this is a good space to kind of give you an idea of what's possible in this. I think one of the other ones I did is here. Why is the sky blue? I like this one is this Wikipedia assistant. Many of you might be working with folks that have lots of data that want some type of question answer system to do that. I think this is a super cool demo. You type in why is the sky blue? It generates an answer for this. And if you're well, where do they get its information from? That's down below. And so what it's actually done is found 4 different documents that talk about why the sky is blue. And then it's stitched together a final answer into a nice cohesive English for that. So for me, this is always an impressive demo to give to people kind of around this. And you can even have folks to kind of type in your own things. But I want you to be aware of where it is and how you could build this out yourself if you wanted to as well. Okay. I wanted to make sure I got spaces in there. Let's go ahead and see what other questions there are. I skipped a bunch of stuff on how to build your own pre-trained model and around that, but we'll see.
I think there was one question about pushing to the hub from Shah. So the question is push to hub necessary? Will the model still fine-tune and be usable without it?
Yeah, so the push to hub is not necessary. Again, it's just taking the model weights and putting it out on the Hugging Face hub to do that. You don't have to do that. You can just take the model weights and keep them where they are and move them to something else. The reason I kind of have that push to hub and the finding here is when you're using Google Colab, your instance is going to die. And so you don't want to spend 4 or 5 hours fine-tuning, training a model, and then have your Google Colab instance die and go away. So what it is. So you'll see you can run this just fine. And you can even try it right now by removing, let me see what happens if I comment this out. We'll just try it, do it live right here and see what happens. There it goes. You can see I got it running just like that. So no need at all. In the notebook, I've also have a whole section on inference. Didn't talk about that today, but an important thing is you've built these models. You want a number of different ways to be able to kind of get predictions out of them. That's in there as well. I even, for this fine-tuning example, added some homework. If you're new to this, see if you can improve how the model works by adding more training data, more, if I could spell right, more epochs. Try it with using, I use Distill BERT. Try it with using the full BERT model. It's a larger model. It's going to take time. Or go and start with a pre-trained model that's been built just for working with financial data. And so I linked to this FinBERT pre-trained model here, and you can go and try this one out as well. Get a sense of what are the differences and the trade-offs between those pieces like that. So, thank you. I need to send Bintal a huge beer or food or something like that, because thank you for prompting that, because I like to promote myself, and now you've given me the blank check to do that. So I like data science. I have a lot of fun writing it. So I'm at Registics. You'll find Registics on YouTube, on Medium, on LinkedIn, on TikTok, on Instagram, all those places. TikTok is like the big short media thing. I do a lot of TikToks like that. LinkedIn, I do a fair amount as well. Feel free to connect with Andrew and I on LinkedIn as well around that piece like that. So I don't know how we get the recording of the tutorial like that. The other piece is at the end of this, please make sure you give like a good review. Maybe next year I can show up in person and get to see all of you guys. It would be cool to do that as well, like that. All right. Go to the replay tab on Hopin. Excellent. You're solving your own questions like that. Anything else, Andrew? You got the last few minutes. You've had the big 20,000 view that you think we should talk about here in the last few minutes?
No, look, I think you've covered it. You know, this was intended to be like an educational workshop on transformers, giving people a taste of what you can do with that technology and how easy it is to do now. You know, I'm going to be there in person. If you want to talk to us about the open source stuff, the commercial stuff, you can come find me.
Excellent. All right. Well, I think we will call it at that. Again, reach out to any of us if you need anything. I'll hang out here for another minute or two if there's any other questions. But no, thanks to everybody for coming. I know it's not fun to sit and listen to this notebook stuff, so appreciate your patience as we go through this. So it was good to have you guys all along like that. Yay.
Okay, looks like there's no more questions.
So yeah, no. We had a good turnout, huh? There was like 50 some odd people, I think.
Yeah, still 43 people in the room. Cool. All right. Thank you, everyone.
Thanks.
Thank you so much, Rajiv and Andrew. Yeah.
Thanks.